Harrington. Dan is going to be speaking on plant growth regulators. And I'd just like to thank Famous Peppers Pizza for supplying the pizza for lunch, and Mary's Bake Shop for the sweets and the cookies that you had. So, Dan, take it away.
Okay, thanks, Peter. Okay, everyone, I guess I'm going to give you a presentation here. We had a project going where we looked at plant growth regulators on wheat and barley. So I'm Dan, and I've been here working with AAFC just for 3 years now. So first off, what we looked at, or what I'll be covering, is just an introduction as to some of the plant growth regulators we tested, which was only 3. Go over the design of the project and then some of the results. So this project has been running for, we just finished the 2nd year, and we'll be going into the 3rd year here this spring. So first off, the 3 plant growth regulators that we tested were chloramiquat chloride, which is also known as manipulator, ethifon, which is the active ingredient for ethyl, and trinexapac ethyl, which is the active ingredient for modus. And the only reason I'm putting those, it's easier for you guys to remember the trade name than the chemical name, so that's the only reason I threw those up there. So basically, what are plant growth regulators? Well, essentially, they're just chemicals that act upon plant hormones. And anything that affects the hormones affects the growth of the plant. And anybody here with teenagers knows that hormones can drastically affect a living organism. So if you have a plant hormone, basically they can be grouped into 2 classifications. You can have growth promoters and you can have growth inhibitors. So ones that make things grow better and ones that reduce the growth. So there are many classes of growth hormones, and here auxin, cytokinins, gibberellins, ethylene, and abscisic acid. The 3 plant growth regulators that we tested only act upon these 2 hormones here. So we'll get into that. First off, gibberellins. And I apologize if I'm loud in this. I'm naturally a loud person, but you'll hear me, that's for sure. Gibberellins, so they're a group of plant hormones responsible for cell elongation. So when I say cell elongation, that's not just the stem, it's also the leaf for making them longer, and the roots. They're naturally produced in the roots, and they go up into the plant when the plant needs them. They produce more when they need them. So you can just imagine that after tillering in cereals, they produce more, and then all of a sudden the plant starts to stretch. So that's a growth promoter. And what happens is essentially this. You have cells beforehand, and once gibberellins act upon them, they lengthen. So those 2 chemicals here, manipulator and modus, both act as gibberellin inhibitors. So they prevent gibberellins from going and allowing that cell elongation. They stop cell elongation, not totally, but they act upon that. So that's how those work. Ethylene is the other growth hormone that's affected. And so it's often considered the aging hormone in plants. You know that if you put a ripe apple in with something in a bag, that it helps promote the ripening. You've seen these green bags. The whole idea behind them is that you put your fruits and vegetables in there, and the green bags, they latch onto the ethylene and prevent or extend the life of your fruit or vegetable. That's the idea there. So they're best known for their effect on fruit ripening, but they also can impact elongation and many other aspects of plant growth. So ethifon So ethyl, what happens is when you spray that onto a plant is that it causes ethylene to be produced. And ethylene in cereals causes cells to limit elongation, and in fact they actually widen. So instead of going lengthways, the cells actually get a little bit wider. So that will increase your stem strength, and it stops them from stretching. So that's basically, that's those 3 plant growth regulators that we tested. So we tested them among other factors. So we want to look at more than just the plant growth regulators by themselves. So we looked at variety. We used 3 different varieties, and then we also looked at fertility. And this is basically what it looked like, say for wheat. We had 3 different varieties, Walton, Scotia, and Easton. And then we tried different fertility levels on those. So we had 3 levels of N, that's the total units of N that the crop received. So 80, 110, and 140. We wanted to push it a little bit with the 140, hoping that we would trigger the plant to fall over a little bit. It didn't end up happening. And this is just another way of looking at it, just for this one variety, Walton. We have it divided up to 3 plant growth regulators here, and then we have the control plots that didn't receive any, but they still received the fertility. So you can see how an experiment really, and then did it for Scotia and for Easton, and then the same for barleys. So you can see how an experiment kind of blooms when you get going here. Go back. So here for barley, we used Leader, Island, and Champion. And then the same treatments, except that the nitrogen levels were different. For the barley, we tried 55, 80, and 105 units of N, hoping the 105 would push the barley. So just a little bit about the timing of when we put these growth regulators on. We did it according to the label. So for Modus, we put them on at Zadok 31 to 32 is when it says. So that's just when your first and second node are starting, basically right when the plants are thinking about, or they're starting to stretch. The manipulator, around the same timing, although you have a much wider window, and that's why some producers really like manipulator. You have from Zadok 31 to 39. So essentially right from when they're starting, right to the flag leaf. And then ethereal, here it says Zadok 37 to 45. Which is it's not a very long window there actually, that goes by quite quickly. And so we sprayed the Modus manipulator on June 27th, that was in 2018. It was nice that we could get both of those on at the same time. And then the ethereal went on a bit later, on July 5th, and similar timing here in 2019. I thought I had another picture. So essentially that's what our trial looks like. Each little line there is a plot. And then we overlaid our plant growth regulators on top of that. So each color is a different plant growth regulator that went on. This is essentially what the plots look like. And this was around that growth stage there that we ended up putting the chemicals on, the regulators on. This is Chris Fleming, our technician here. This is how we apply them. We have a small sprayer here. We have two plots, 2 guard plots in between each treatment. So he has some wiggle room right there to stop and get it shut off so that we're not overlapping or putting too much on a particular plot. Oh, again. So this is what the area looked like in 2019. Here is these are our barley plots, and these are our wheat plots. Just another view. Here we had some disease ratings being taken at this point. And these are the little combines that we use to harvest the plots here. And thanks to Sharon Terbeek for helping me get those plots off this year. So results, this is it. This is what it's all about. First off, we're going to look at barley results first. The first one we'll touch on are plant height. So, how did these plant growth regulators affect plant height? So here's the control. So that received no plant growth regulator. So the height shouldn't have been affected. So they should be taller. Well, we can see that. They're quite a bit taller. That was 75.7 centimeters. The manipulator over here was 74, on average 74.9, so no real effect on barley seen from the manipulator. The ethereal, huge impact on the barley, 63 centimeters, and the modus, which is a newer product. I'm not sure if it's available yet to producers, but it will be in the near future. That was here at 68. So they significantly affected plant yield, and so that's just to go back quickly, that's the averages over all treatments. We're looking at all the different varieties combined and all the fertilities, just looking at the averages for each one of these, and this is what happened. When it comes to yield, there was an impact on yield over the control. So here, about 4,090 or 99 kilograms per hectare. We saw an increase as a result of using the manipulator. It was at 42, 4168 for modus. And this is interesting, is that there was a bit of a yield, there was a decrease in barley that we saw from using the ethereal. So yield by variety, we had the data, just thought I'd show it, just to show that leader and champion were the top two. They were very similar, only a kg in the difference on average, and Island was a bit lower. When it came to protein, we saw that the plots that received ethereal had higher protein. These bars are exaggerating this quite a bit. It's actually not that big of a difference if you see the numbers right here. So where it looks like it's huge, it's not really. That was 10.9, basically 11% protein versus 10.7 on the control there. So although the ethereal reduced yield quite a bit, the protein was a bit higher. Protein by fertility, and this is what you'd expect. The 55 units had the lower protein, and the 105 had the higher on average, just like you'd expect. Protein by variety, in general, although Island was a little bit lower, it's probably one of the reasons it's so popular. It had higher protein, pretty good feed value. So Island had the highest, followed by Leader, and then Champion. Champion is a newer variety. I don't know if anybody here is growing it. I think it's a little bit more popular in New Brunswick. When it came to test weight in the barley, this is what we saw. This is grams per liter, not a half liter like you might be used to seeing. So just divide the number in two. So here's the test weight of the control. I don't know why I came up with 666. I should have changed that to 667 or something, just so we weren't unlucky here. But anyway, that's what it was. Manipulator didn't have any effect on the test weight, but ethereal and modus seemed to decrease the test weight a little bit. So when it comes to variety, this answers one of the things we're looking into. Do some of these plant growth regulators work differently on different varieties? Well, with regard to barley, no. We didn't see any significant effect. You can see the same trends here. So gray is ethereal, blue is manipulator, the orange is modus, and that's our control there. You can see the same trends regardless of the variety. So we didn't see any difference there, and we answered that question. No significant effect on the based on barley variety. Disease. I don't have a whole pile of disease data here. Just with scald, we could see that there tended to be a little bit higher, some higher levels in the Modus plots over the others, but nothing significant really. And no significant difference between Fusarium indice or severity, incidence or severity. And I don't have Dawn numbers to show right now, but next time I ever give this, I'll be having Dawn numbers. So this is the stuff that you guys might find very interesting. So this is the cost benefit. I have it broken down into 2018 and 2019. And I expect to get stuff thrown at me here. I don't know what you guys will think of this, but I found it very interesting. So essentially, here's our average yields here from the plots. This is a metric ton per acre. So chloramaquat, this is the manipulator, ethyl, Modus, control. What I did is that this is the average. So then we take this number, the average for, say, manipulator, we subtract the control average, and that gives us the benefit. So there was a benefit of 0.03, basically, metric tons over the control. So then we take the cost per acre of applying that product at the recommended rate, which for me was $15.23 an acre, subtract that, and this is what you'd get as a profit per acre as a result of using that. And that was minus, so you lost about, from our numbers, you lost $8.50. This is crazy. I didn't fudge these numbers. This is ethyl. We used that, we got an average yield of 1.73, but the control we had 2.13. So the difference is 0.39, basically 0.4 ton per acre. We subtract the cost of 1093, and we lost about $100 an acre. I've thought about this. I didn't know if I should even present it, but I think it's accurate. We went over it. But it's important to note that barley isn't on the ethyl label, maybe for that reason. For the new product there, which would be known as Modus, in 2018 we saw an increase, so we saw a benefit of $12 an acre. 2019, for barley, we were in the red here all along. So we had higher yields in our plots in 2018, higher barley yields for us in 2018 than in 2019. So I have this same get-up done for wheat, and we'll get to that in a little bit. It's a little bit more optimistic. So these products, as it pertains to wheat height, it's as you see here. So no plant growth regulator, we had about 100 centimeters tall on average. We add Modus, we were down to 92. Ethyl brought wheat height down to 89. Manipulator brought it down to 84. So, yeah, it affected plant height. When it comes to yield, yeah, there's significant effect here where we actually saw an increase in yield. This is on average, looking at all different fertility levels. We saw that manipulator actually increased crop yield over the control more than the others. Fertility, just like I showed you there before, as you'd expect, yields increased with increasing fertility. Had 140 units of N there for wheat, like I said, hoping to knock her back a little bit. Yield by variety, Scotia and Easton. Our Easton was a little bit higher yielder than Scotia. Both were a bit higher than Walton. As it pertains to test weight, here we go. Ethyl had the most impact, had a higher test weight over the control. Manipulator, although the highest yielder, and it's also, as you'd expect, the highest yield, you'll get the lower test weight. Protein, another important factor when it comes to wheat. Again, increased protein with increasing nitrogen levels. 12.3, highest was 13 on average. If we pulled out, we had some pretty high protein levels if we went through the data and pulled out some of those 140 plots. And on average, protein, it looks like there's a big difference there. That big jump is only 0.1%. So there's not a real difference, and there was no significant results here when it comes to protein. So the regulators didn't seem to affect that. When it comes to variety, this is what we saw. Do the plant growth regulators affect varieties differently? The stats said, yeah, they kind of do, but not really. If you look here at these numbers, and this is just in terms of height, what we'd be looking at here are trends. The trends seem to look the same here, where we have the height as highest in the control plots. Second is the Modus product. Third, for the most part, and this is where the stats would have saw the difference, where they're kind of equal here, the ethereal and the manipulator, but ethereal is higher here, the plant height's higher, Scotia. So they saw a little different, but basically there's not a huge effect between varieties as it pertains to plant height and how these growth regulators affect that. Okay, here are more numbers, and I have another set that are interesting as well right after this slide. So this is looking at wheat. This is 2018 and 2019 data. Oh, so back with barley, when I did that cost of production, I guess it said it on there, I was looking at $225, barley worth $225 a ton. Here we're looking at feed wheat if you were getting $250 a metric ton. In 2018, we didn't see any benefit. Looking at these numbers, it would have been in the red using the product. This is if we were just going with moderate fertility, not trying to get milling. We're not going to see a huge benefit here. 2019 though, our yields were higher for our wheat, and over the control, we would have seen that we could have made an extra $23.77 here per acre using this manipulator product. There was an advantage. Only 30 cents per acre. Now this doesn't take into account the cost of passenger driving through your fields, right, to put the product on. There's a few variables here not included. This is looking at just the price of the grain over treated grain over the control and the price of the product per acre. Now, but why do we put plant growth regulators on? We put them on because you kind of want to push the envelope. You want to try the higher fertility levels, right? You want to be able to push that fertility and not have the plants fall down. That's why we use them. So if we look at this is looking at the 140 units. So the treatments that received, the plant growth regulators that received 140 units of nitrogen total, and control that received 140 units of N. For instance, with manipulator here, there was a 0.17 metric ton difference between the two, control and that. And subtracting the 1523 cost per acre, we resulted here in a gain of about $31 per acre over the control. That's not too bad. Now here, and I didn't mention this, and this is really important. For this Trinexpac ethyl, which might be Modus, there's no price out for that yet per acre. So I just used the same as the manipulator. I assume it'll likely be around the same price, so I just went with that. And if it is around that price, then there was a benefit of about $20 an acre seen just by using that product. And there's also the benefit of your crop probably not falling down. So that's that. And that's that project. I'd just like to thank all of these people that helped made it happen. I couldn't have done it without them. Chris, Allen, Sharon, Jennifer, Nancy, Nellie, Dr. Foster, and Dr. Mills, and Ron Matter, Sherry Fillmore, Christian Gallant, all these people helped me at some point over the last 2 years to get this completed. But anyway, I'm open to some questions.
The last slide, you had the same results for the barley at the 105.
What's that?
This slide here at 140 units of nitrogen on wheat. Do you have the same data for the barley at the 105?
Yes, yeah, that's back. Oh, I'm sorry. No, not at the highest level. Sorry about that. These are just the mean, so that's something I could have pulled out. The data was looking at just the highest 105 rates.
At the higher rates of nitrogen.
I don't know what I saw in terms of, I don't know what I saw in terms of a cost benefit. Right now, if you saw the load of data that was there, you kind of have to pull it out and look at it individually, and I didn't do that. So, yeah, so I don't know what it is just looking at those higher rates.
Dan?
Yes.
A couple questions here. One, some of the chemicals you can mix with your herbicide if the time, and some you can't. So if it's one you can't mix and you have to make a separate spray pass, I'm assuming your production cost is not taking that separate pass into account. Is that correct?
Yeah, no, it's not taking any of that into account there, David.
Okay. The other thing, yeah, we do that. That's part of our free package, right? Another thing, the wheat and the barley with the growth regulators, it's almost a complete reverse of the effects. Is there an explanation why wheat higher yields, barley lower yields with regulators?
Yeah, not one that I'm really aware of yet. They are, although they are cereals and they're very similar, they're also very different, different genus and species. So they just behave differently. But I don't have a proper explanation as to why that's happening.
Because one of the things in the Yen project that we're being shown is sunlight capture, and I guess and I think I've heard in some of the discussions that taller plants are capturing more sunlight. I don't know if that's at play in this or not. But the other thing is, what about the lodging and head loss, for example? I'm assuming that if the growth regulator stiffens up the straw, you're going to have less neck breakage or less head loss. So that's going to reflect in the yield, which reflects in the added value of it. Have you noticed and have you taken any look at how the growth regulators are actually affecting harvestability and head loss and things like that?
No, we haven't looked at that. Just general observation behind the combine, it didn't look like we had any more loss as a result of any of the treatments over the control. These are pretty good little combines that we're using, and I didn't notice any extra trash or anything in. And we fine-tune them pretty well, so we get very clean samples at the end of the day, but we haven't noticed anything there yet, David. But this is all more stuff to look at.
Dan, I was looking at these numbers, and I guess I've used manipulator and used Ethro before, and I've always felt it got me a better crop, bigger crop. When I look at these numbers, there's something going on, because I wouldn't use it again if I went by these numbers.
Have you used them on barley?
Not yet.
No, but they're not too bad looking when you look at the wheat numbers.
But I guess I'm wondering if there's something astray here. Looking at some studies that have been done in other areas, they found that you can manage these crops, but to manage them you got to put fungicides on too. In these trials here, you've got no fungicides applied on them?
Nope, no fungicides.
Like I've read and I've seen in other areas, they've done this work on wheat, and they're finding it out in barley too, that in order to get the true benefit of one, like higher nitrogen or adding plant growth regulators, you also have to apply fungicides. When they put the three of them in one treatment, then they do see a definite net gain. And I'm wondering if that's something we shouldn't be looking at on a go-forward basis.
Definitely. You can see how that experiment was quite large, right? We were looking at a lot of different variables there, and once you add in another factor like a fungicide, well, then it kind of balloons. But in general, I think that these results are kind of promising for wheat anyway. Like there was a significant increase over the control just by applying that spray, and it's just intended to shorten the stalk. I don't think they're promoted to be a growth enhancer. They're not promoted to really increase your yield unless you add extra fertility and things. But just stand alone by themselves, these three products seem to be increasing yield, and that's pretty important. Maybe the next phase of the project, the Grains Council would like to see the interaction. What you're suggesting there is a synergy, right? A synergistic effect where 1 and 1 doesn't equal 2, it'll equal 3, and that's quite possible. I'm a firm believer in fungicides. I know they work very well, but for this project, we weren't testing those. We don't have that data.
Hey, one little question I had was in your control varieties, was there any sign of any lodging in any of your plots? And I take it when you harvest those plots, even if there is lodging, you're getting 100% of your crop. You're not accounting for harvest loss due to lodging.
Yeah, unfortunately, and you'll never hear anybody ever say this, but unfortunately there wasn't any any lodging. We put in the 140 hoping that we would knock it down, and once we saw that even the control plots weren't falling down at 140, it made me, and that's even with Scotia, which can sometimes fall down under high fertility, it started making me think like, man, I should really increase that 140 to a higher level. And maybe that's what we'll do in the future, is really push it and see what happens. We're not out of time yet?
Oh, sorry.
I think we're out of time.
Yeah, so Dan and I have gone back and forth with this quite a bit. And again, drawing from the yen, we had the farmer from the UK. We got to interact with him quite a bit. And he said that he would never dare put growth regulators on a spring cereal because the growth stages, like things are happening so quick. And where you have a winter cereal and they don't have winter, they can take their time and hit it exactly when it needs to go, right? So the label is, what is it, 31 to 37 or something like that? Mm-hmm. Yeah, so in the UK, it's like 30, 31, 32. And like those are very specific times when you need to hit this. So I think Dan has a lot of factors in here, and I think it's amazing that he was able to pull these out given the number of factors, but like it's really, these are very, I guess the plant is very sensitive to these chemicals, and you have to hit it at exactly 30, like it says 31, 32. It's like 31, 32, that's it. So I know in places where they do use, especially Modus in the UK, they are extremely precise on when they're applying these products. And that's why we don't tend to see responses is, we do have a bit of a range, and people tend to take that range for granted type things. Just a comment.
Yeah, and one thing before I go, which something interesting for future research, I was talking to somebody who knows a lot about manipulator, and there are some trials that have happened out west where they're actually trying a tank mix. They're mixing manipulator in this new Modus product, and they're seeing that synergy that we talked about, seeing a bit of a bump over either of them alone. So that might be some interesting research for the future as well.
And be thinking of those questions on research with those cards that are on your table. If there's any questions